Hello and welcome to a new video in the right-angled triangle series, or right-angled triangle series I should say. This lesson is all about trigonometric ratios. So one of the things that we need to remember about trigonometry is that it's all about measuring in triangles. So that's literally what the word means. And we're going to be dealing with trigonometry in right-angled triangles. This is because we are doing right-angled triangles unit. Now, in terms of trig, we have a couple of different things that we talk about in ratios. So things in comparison to other things of the same type. And the first thing that we need to be able to do is we need to be able to identify certain things. Okay? Need to identify certain things. So the very first thing that we need to identify is this idea of an angle name of theta. So this is theta here. It's a Greek letter and it is really commonly used to label angles. There's a couple of other Greek letters that we use, such as alpha and beta and phi. We'll come across those sporadically as we're doing things in trigonometry. And everything that we do in trig is based around the angle we're dealing with. So in this case, we're dealing with the angle theta, which is down here in this corner. Okay, it's down here in this corner, so everything comes off that angle. The hypotenuse of a triangle, is always opposite the right angle. So we do need to remember that. Always opposite the right angle is the hypotenuse. So that one will never change. However, the other two sides will change their names depending on which angle we're using. So we're using this angle down in this bottom corner. So across from it, directly across is the opposite side. It's directly across, and then adjacent is next to. So adjacent means quite literally next to. Okay, so if we were to look at our example here, a little quick example. What are the values of the hypotenuse, the opposite side and the adjacent side of the triangle shown? So here's the angle we're dealing with. There's theta. Okay, and it's showing the important angle. Okay, so the angle that we're currently dealing with, the one that we want to use, etc. So we can see here that 5 is the hypotenuse. It's going to be 5 simply because it is across from the right-angled triangle. So it will always be the hypotenuse. Alright, the hypotenuse there. And so now we need to decide which side is opposite and which side is adjacent. So I'm going to pop the words opposite and adjacent right there. And we're going to have a look at this diagram. So if we look at this diagram, we can see that next to that angle is the side with the value of 3. Okay, so this is the adjacent side. Okay, the adjacent side now is 3. It's the one next to the angle. Okay, it is directly next to the angle, so it is adjacent, it is equal to 3, which leaves the other side being opposite and being the value of 4. So that's fairly straightforward in terms of which side is which on the triangle. Now that we have that, we can actually work out what some of those trig ratios are. So we have 3 main trig ratios that we deal with. 3 main trig ratios. I'm just going to move that all the way up. We have the ratio of sine. We have the ratio of cosine, which simply means the complement of sine. So these two go together quite nicely and they complement each other. And then we have what we call tangent. Tangent also has a complement, but it's a little bit different and is one of the ratios that we don't really need to worry about right now. Okay, so let's have a look at what we're looking for here. We're looking for the trig ratios for sine theta, cos theta, and tan theta. So we always shorten to just the first three letters. So it is sine theta, cos theta, and tan theta. Okay, now to get sine theta, we want the opposite side. This is why it's important to have those different sides labeled. Opposite over hypotenuse. Okay, so we want the opposite over the hypotenuse for sine theta. For cos theta, we're going to look for the adjacent over the hypotenuse. So see how they actually complement each other quite nicely? They do the opposite thing to each other, or they sort of fit together like puzzle pieces. So sine is the opposite, cosine is the adjacent. And then we have tangent or tan theta. Okay, and as you can imagine, tangent being something slightly different. This time we're going to have the opposite over the adjacent side. Now, this is where we actually come across something that we like to call SOHCAHTOA. Okay, we quite often use this as an abbreviation, as a bit of a way to remember these ratios. Okay, SOHCAHTOA. Now, I know it sounds a little bit like the name of a volcano, but it's not. It's just the name of our trig ratios. And what it is comes from the abbreviations. Okay, so if we have sine theta here, it is O over H, or the SOH part of our word SOHCAHTOA. And then cosine or cos theta is A over H, which is the K part of SOHCAHTOA. And then tan theta being O over A is the TOA part of our abbreviation of SOHCAHTOA. Okay, so that's fairly straightforward so far. Let's have a look at some of this in action a little bit more and look at some new examples. And as always, our examples are coming from the Cambridge Mathematics Standard 1 textbook for New South Wales. Here we have the first of two examples that we're going to look at. We have find sine, cosine, and tangent for the angle theta in the triangle shown. Okay, I'm just going to change my color again. Here's our relevant angle. So this is our relevant angle. Marked with a theta. Okay, and now from there we can label our sides. Now we already know that this is the hypotenuse. Okay, so that makes this side over here. Hope you're getting this at home with the opposite side, which then leaves the remaining side to be the adjacent side. And that's what we're going to need to do as we're moving through these to determine what our ratios actually are. Alrighty, so let's have a look at the sine theta. Now, sine theta, alright, is O over H. Alright, so opposite over hypotenuse, which for our purposes and our triangle here will be 8 over 17. 8 over 17, there is our sine ratio. So we call these a ratio because it's things that are in comparison to each other. Then we have cosine theta. This one is A over H. Alright, and I'm sure you can guess this one. It is going to be 15 over 17. And then, of course, we have tan theta, which is O over A. Or in terms of our actual triangle that we have over here, 8 over 15. Fairly straightforward, I believe, and hopefully you're understanding what's going on. Okay, one more example here. Here's our example here. We're going to find sine theta in the simplest form, given tan theta equals 6 over 8. So again, there's our relevant angle. We already know that this is opposite. We already know that this is adjacent. And that leaves this as the hypotenuse, which you could also tell because that is directly opposite the right angle. So here's our little right angle in there. And we need to know what the length of that is in terms to make this problem a little bit easier. So this is where we need to go back to some of our previous lessons and Pythagoras. Okay, so we're going to use Pythagoras to work this little fella out. Okay, so I'm going to start with our formula. We're looking for the hypotenuse of the triangle, so we're going to use our h squared formula. Okay, we're going to use the h squared formula to find this one. So h squared is going to be 6 squared plus 8 squared. Now, because this is plus, it doesn't matter if you do 6 squared first or 8 squared first. It's going to be the same. All right, h is the square root of this. Okay, and then when we work all of that out, we actually get an approximate answer of 10. Okay, so 10 is our final answer for that part of the problem. So now we know that the hypotenuse equals 10. And now we can find sine theta because now we've got the hypotenuse and the opposite side. So sine theta being O over h is going to be 6, because 6 is the opposite side, over 10, which is the hypotenuse. And we always, or almost always, will go for simplest form, particularly when it's in the question. So make sure that if your question says simplest form, you actually do simplify your fraction. Okay, and this is going to become 3 over 5. Hopefully this video has been a little bit of a help to you. This is all it takes to get through some of these things. Therefore, we should be pretty good with it. Hopefully this has helped. Go and have a go at some questions. Good luck with those, and I'll see you in the next video. Thanks for watching.